crunch time. We're almost done, so let's do this. Okay. So polygons, it's a closed shape. It's always a closed shape with the same number of sides and angles. This is important for you to know. Same number of sides and angles. Okay. I will make a note at the top here. Note. Triangles and quadrilaterals are also polygons. Because sometimes students think, oh, those are like a different category altogether. Yes, they have their own special category, but polygons is kind of like encompassing all of them. You don't need to know this part, but there's a difference between convex polygons and concave. Concave is if obviously it's caving in, right? Like the sides actually go inside the shape. We're not going to worry about this one. However, this one you do need to know. You know what I'm going to focus on? Because every year there's a bit of confusion. So I'm just going to say, how do you identify a regular polygon? All sides are equal. All angles are equal. That's all you need to know. If you look at any shape that doesn't meet this criteria, it goes into the irregular camp. Okay? Can you have this on your study sheet? I think if you just have this, you're gonna get it right, because you're gonna look at whatever the province presents to you and you're gonna be like, wait a minute, are all angles the same? Are all sides the same? If the answer is yes, it's a regular polygon. If the answer is no, you're going over to the irregular side. Okay? So the two examples that I can tell you right off the bat is an equilateral triangle and a square. Those are the first two shapes that are definitely regular. Okay? Because in an equilateral triangle, all angles are 60 every time, no exceptions. It doesn't matter if it's a large equilateral triangle or a small one, the angles are always 60. Same with a square. All four angles are 90. Okay. And then sometimes students are confused, right? So let's look at this rectangle here. All the angles are 90, correct? Oh, so all angles are the same, but are all the sides the same? Right? So that's why it's in the irregular camp. So you got to kind of distinguish between regular, irregular. That's all I'm going to say there. I'm going to leave it at that. So make sure you have this on your study sheet. Regular polygon, all sides, all angles are the same. Next. Some properties. All polygons have interior and exterior angles. The interior and the exterior angles are supplementary, meaning they add up to 180. And here's where I would encourage you to have two different colors. Okay, I'm going to go to page 50 here. If you have colors, that'd be great. So every polygon, this polygon, for example, has interior angles. It has 5 interior angles, right? And here's where you just need to know this. When I count the sides of the polygons, guys, I go put a check mark. 1, 2, 3, 4, 5. So that I won't double count. So this one has 5 sides. 5 interior angles. And it will have 5 exterior angles. Where are the exterior angles at? I will show, right now I will show you one of them. you take your ruler and you pick one of the sides. Like at this corner, there's two sides that meet there. You pick one of them and you extend that side. Okay? And there you have your exterior angle. Can you see that they add up to 180? You see that straight line? Right? A straight line always adds up to 180 if it's cut up. Let's go to another, let's follow this side right here. If you extend that side, you've got an exterior angle right there. Go over to this side. There's only one exterior angle per corner, right? Per angle. So 5 exterior angles, 5 interior angles, right? So if you know either the exterior or interior angle, you can find the other. Example, if I were to tell you that the interior angle at this corner is 120 degrees right here, you should immediately know what the exterior angle is at that corner, because you know they add up to 180. So the exterior angle would have to be 60 degrees in this case, because together they always add up to 180 degrees. So that's the cool part. If you know one, you can find the other just like that. Okay? Another piece worth highlighting. So I will make sure this is boxed in. I will make sure that this is boxed in. Watch this. The sum of exterior angles. Exterior is always bless you. It's always 360. Right? It's always 360 no matter what. I said exterior angles, okay? So this thing could have 100 sides with 100 exterior angles. If you add up all those 100 exterior angles, it will always give you 360. Exterior, not interior, okay? So that's a pretty cool property right there. All right, let's keep going. So we know regular polygon. We know that every polygon has the same number of sides, interior angles, exterior angles. They're always the same. We also know that the interior and the exterior angles at any given corner add up to 180. Okay, we know that as well. So here are formulas. Good news about the formulas. I mean, it's up to you how you want to tackle it, but they are provided on the formula sheet. Okay, so I will tell you in a bit what they mean, because it's important that you know what they mean. I tried something. You're going to be psyched to learn about these formulas. I tried something. I know it doesn't spell psyched, but if you go to your formula sheet, they don't have it in the same order, or do they? No, they don't. They've got S, interior angle, exterior angle, central angle, and diagonal. So they have all those formulas there. And one thing to remember is that n represents the number of sides of that polygon. Okay. So what does every formula, you need to know that. Let me highlight this. Stay with me, stay with me. S is the sum of interior angles. If you want to know what the interior angles all add up to, use this formula, okay? If you want to know the measure of each interior angle, use that one. Use this formula right here. If you want to know the measure of each central angle, use this one. I will show you where they are, so don't panic just yet, okay? If you want to know the measure of each exterior angle, use this formula. And notice that they are exactly the same. That's not a typo, that is a fact, okay? And if you want to know the number of diagonals that can be drawn, use this formula right there. So this is how to help you remember. If the question says, how many diagonals can you draw? Use this one. What's the measure of each exterior angle, each central angle, each interior angle? What is the sum, the addition of all the interior angles, right? So that's, you kind of have to pick the right one based on the scenario, okay? For D, what am I asking there? What is it asking? I inserted a picture here. So, for example, a square can only have 2 diagonals, that's it. You can actually draw it and you're done. But what if you had like an octagon? Can you see how many diagonals are in there? A lot of diagonals, okay? So this formula calculates how many diagonals can be drawn, okay? I will also say this, maybe I should just leave it for now. Yeah, I will leave it for now. We'll talk about it tomorrow. Let's calculate this. I'll show you how to calculate it, how to use the formulas, and then you'll practice a few today so that you at least get a bit of a handle on them. Label ice, then calculate psych. I want you to calculate all of these, okay? What is ice? I stands for interior angle. So let's label one of them, one interior angle. You pick any corner you want. Just make a little arc like that and put the letter I in there. That is one interior angle that you've labeled. That's all you need to do. C, central angle. Think of center. You put a dot at the center, and then you're going to slice up the pizza, right? I'm still waiting for more pizza, Tyson. Just saying. You slice it up, right? You go to the center there. You use one side and slice it up again. And that's not it yet. You're not done yet. The central angle is this. This is one central angle. How many central angles will this thing have? As many as it has sides. So technically you've got a bunch of central angles. You've got 5 central angles because there's 5 sides. There's 5 central angles, but you've only identified one. The next one is the exterior angle. I like to do it right next to the interior angle, so I'll just extend the side like this and just make that the exterior angle. Boom. 1 year, the provincial exam, this is all they asked. 3 marks. 1 mark for each label and you were done. Moving on, okay? Can I just tell you what is not okay with the exterior angle? Some students just go out like this and they label that as the exterior angle. This is wrong because it has to follow the pattern of one of the sides that meet there. So this would be wrong, okay? So please don't make that mistake. Just remember, you travel along a side and just keep extending it as if you're not turning. Right. So let's calculate this. Let's do the sum of interior angles. It calls for n minus 2 times 180 degrees. What is n? You have to figure it out. You have to count. 1, 2, 3, 4, 5. So we're going to go n, s is equal to 5 minus 2 times 180. That ends up being 3 times 180. 3 times 180 is 540 degrees. Sum of interior angles. Okay, that's what you found here. So if I asked you, if I were to add up all the interior angles in this shape, it would add up to 540. Yeah. Yes, n is the number of sides. So how about we go n is equal to 5 sides to make sure we understand that? Yes. So this 5 is what I inserted there. Okay, next, in no particular order, but interior angle is n minus 2 times 180 divided by n. Don't forget that. It is very similar to the sum of all interior angles. Watch how it starts. But then you end up dividing by the number of sides. And the reason you do that is because you're trying to find out just one. Like, what is one angle? What does one of these interior angles measure? So we're going to go 5 minus 2 times 180 divided by 5. That is 3 times 180 divided by 5. That'll give you 108 degrees. Measure of each interior angle. And now we're down to the central angle. I'm going to do this here. Central angle is 360 divided by n. So it's going to end up being 360 divided by 5. That gives you 72 degrees. One central angle. I don't know, I don't want to talk too long about the formulas, but does it make sense that it's 360 divided by n? Think about it. If you were at the center and you go a full circle, that's 360, right? You're splitting 360 into 5 equal angles. So that's why you end up with 72. So it's 72, 72, 72, 72, 5 times, and you get your 360. Okay. Fun stuff, I know. Keep going. Exterior angle, it's a little bit cheating here because it's the exact same formula. So I'm just going to say the exterior angle is 72 degrees. However, I talked about it earlier, the exterior angle can also be found by going 180 minus the interior angle of this polygon. Because remember, the exterior and the interior add up to 180. So what's the interior angle? I already figured it out earlier. It's 108. So you still, regardless, end up with 72 no matter what you do. This is one exterior angle. Okay? Last one. Number of diagonals. The formula is kind of crazy. Not really, but crazier than the rest. And what students forget, make sure you copy this down and then you listen to this part. The only formula that has 2 at the bottom is this one. Okay? Students on the final exam, I thought I had it all, we had it all figured out. They put a 2, like they just randomly put 2 in their formulas, like instead of dividing by n, like they'll go interior angle, n minus 2 times 180 divided by 2. And you're so close to getting the right answer, but it'll be off, right? So you'll lose marks. So make sure you know that the only one that divides by 2 is the number of diagonals. That's it. So it's 5 times 5 minus 3 divided by 2. This cannot be a decimal. If you get a decimal, you made a mistake. This is 5 times 2 divided by 2. 5 times 2 is 10, divided by 2 is 5. So 5, don't put degrees, just put diagonals. Or just leave it at 5. That is okay as well. That's it. So I'll just say this, page 52. And some of you are faithfully doing your homework. Keep doing that.